Now, let's look at example one. The car in the figure, which is below, moves in a straight line such that for a short time, its velocity is defined by this equation, which is 3t squared plus 2t, which are feet per second, where t is in seconds, right? So determine its position and acceleration when t is 3 seconds, okay? So that's what the equation wants. But you realize that we are given boundary conditions, and they're telling us that when t is equal to 0, the initial position is 0. So that means that if we are given such a question, we said we need to interpret, we can draw some diagrams if we want to represent, but already the diagram is drawn for us. So now it is easy it's just for us to understand and to know what kind of equation that you're going to apply to solve the problem. First of all, they've given us time, they've given us distance, and they've also they've given us velocity. So we need an equation that is going to describe both of them. But we know from our first equation that we say that our v, right, was the same as, which was ds, right, over dt. And so that was the thing. So now if we look at this, realize that we have a velocity somewhere there, and then we have a ds dt. So that means that we can have ds. And so, whereby if we make ds the subject, then we are going to have ds being equal to v dt. That means that if we integrate both sides, which now we know that if we integrate, so we shall have ds somewhere here is the same as v, right, dt. And so now if we have that and we integrate this, realize that we say that we are moving from s is equal to 0 to a certain distance, which is s, right? And then they told us that we're moving from t is equal to 0, right? And then we're given another t, right? So to t is equal to 3, right? So from there we can define s, right? Because we have v, which is the equation that is given, right? Then we can have that determined. Now also they want us to determine the position, right? So now we're going to have the position right there. Anyhow, let's dive into what already calculated for you, right? So realize that first of all, we need to find the position. So since the velocity was given as a function of time, then the car's position can be determined from what I just been showing you, which is v is equal to ds dt, because this equation relates velocity, right? It also relates position. It also relates time, right? So then this is how what I was explaining, I made ds the subject, and then we integrated, this is what we have. So that means that if we integrate with respect to time, right, we shall have an expression, right? Which expression is now s is equal to t cubed plus t squared, right? So before you put in the t is equal to 3, it's first of all get the expression. Once you get this expression right here, then you're able to then substitute for t is equal to 3. So now when using the given condition earlier, when t is equal to 3 seconds, then we are going to substitute for t in the expression that we have got when integrated from 0 to t, and then we got that expression, and then we substitute in t, we realize that our position would be 36 feet. So the car is positioned, right, 36 feet from the origin, right? So the car is positioned 36 feet from the origin, right? So now, once we have found that, that means we've answered that question, right? We've answered that question. So now let's continue with the question again. And now they want us to find also acceleration. Did the question require acceleration? First of all, so determine the position and acceleration. And so we also need to find acceleration. Found the position. But remember, from our equation, right, for our displacement equation, we've got that we say S is the same as T cubed, right, plus, what was it? Plus T squared, right? That was T squared somewhere there, right? So that is what the equation previously described. Don't just forgive the writing because this pen is not writing well. I'm just using a mouse and it's not perfect, right? So now you remember, this is where was our equation, right? Where was our equation? Let's first go back to the equation that we got earlier on. So our equation was S is equal to T cubed plus T squared, right? So that is the equation. So now for acceleration, we shall use that acceleration is the differentiation of the change in the velocity over time, right? And written as d of v dt. So that means that we can also rearrange it and write it as d of dv dt. So, but recall, this is what we got as velocity, right? Oh, that was the equation that was given as velocity. So now, since we know velocity, so that means that acceleration is going to be the derivative of velocity with respect to time. And so you have to know that. So by differentiation, we shall have our acceleration right here, given by, your acceleration will be given by 6t. When you differentiate this equation, right, you are going to get that. So we shall have 6t plus 2. So now they've given us an equation saying that given a condition that when t is equal to 3 seconds, what is the acceleration? So we are going to just substitute the value of t in this equation of acceleration that we've got. And realize that when you substitute t is equal to 3, our acceleration will be given by 20 feet now per second squared. Remember, guys, you need to know the units of acceleration and as well as the units of velocity. Acceleration is in time squared, right? Time squared. It is in the units of length per time squared. So acceleration of the car would be 20 feet per second squared. So now you need to note, this is very important, that the formulas for constant acceleration cannot be used to solve the problem because acceleration obtained is a function of time, meaning it is changing as the time is also changing, right? Right? All right. So now, let's continue with another example. Okay, let's look at example 2. I think we are going to get this. This will maybe we shall apply some constant acceleration. But now, example 2 says that tests revealed that a normal driver takes about 0.75 seconds before he or she can react to a situation to avoid a collision, right? So it takes about 3 seconds for a driver having 0.1% alcohol in his system to do the same, right? So now, if such drivers are traveling on a straight road at 44 feet per second, and their cars can decelerate. That means that we have acceleration here, which is a deceleration of 2 feet per second squared. Now, determine the shortest stopping distance, which is, we can call it D right here. Okay, the shortest stopping distance D for each from the moment they see the pedestrians. Okay, from the moment they see the pedestrians. So now, before I go into the more of the story, the question here is targeting two drivers, right? And they're telling us that if there's a normal driver and there's also one that has alcohol, right? Or which alcohol? It has a 0.1% alcohol, right? So now, For a normal driver, it takes him about 0.75 seconds for this person if they see an obstacle before they stop, right? I mean, to react and then stop and avoid a collision, right? Whereas if this person has 0.1% alcohol, for this person to react, it take about 3 seconds, right? And if these two people are driving at the same speed on a straight line, which is 44 feet per second, and also they have to decelerate, that means they reduce the speed until they stop with a deceleration of 2 feet per second squared. So they want us to determine to what distance does each one has to go before they stop. So the moral of the story, that is for me and you, is that you must drink. If you must drink, right, please do not drive, right? If you must drink, please do not drive. For you guys who have cars, normally if you're going to drink, in some countries, what people do is that they hire private uh, drivers. So if you're going to drink and there's an app, you have to look for that app. You can hire a private driver just to come and take you home for that, and then you just pay for those few either minutes or that kind of time the driver is taken to drive you. As simple as that. Right. So let's try to now go into this problem, right? Let's try to solve the problem. Okay, so now we need to understand the problem, not so? That is one thing. After you understand the problem, calculation is easier. Okay, now note number one that let's first of all obtain the stopping distance in each of the driver circumstances, right? So when, for example, the normal driver takes 0.75 seconds, so we can have the distance to which this person will stop, right? And also the one who's drunk or having some alcohol will take 3 seconds to stop, right? I mean to react, right? So we can find what distance these people cover. So for the first case, for the normal driver, right? Uh, for the distance, because we are given the speed, right? We're given the velocity, so we're going to have speed times time. So the distance would be the distance covered for this person to react and stop would be the velocity which was given, which is 44 times the time of reaction, which is 0.75 seconds. And then you realize that when you multiply, we shall have 33 feet. So that means that for a normal person, the distance they take for them to react and avoid the collision would be 33 feet. Now, 33 feet is the distance the car with the normal driver will move before he or she reacts and then starts to accelerate, right? The car. So the reacts will first of all see, and then first move that distance, and then his senses will tell him now, put on the pedals and stop. So later on, we are going to calculate what is that distance that this person will have to stop, right? Now, now keep that as maybe our solution one for a normal driver. So now, remember we derived some equations. For now, we need to find out to what distance does this person stop. So the stopping distance for a normal driver can be obtained using remember equation 3, where was it 3 or 4? Equation 3, I think. I think this would be equation 4, where we derived. Yeah, this was equation 4, where we got that v squared is equal to v naught squared plus 2ac into s minus S naught, where S is the final distance, whereby S naught is original position, and then V naught is initial velocity, and V is the final velocity. Realize that if now this driver is decelerating, that means the final velocity, V, is equal to 0, right? And the initial velocity is given by 44 feet per second. So now we can substitute in, and we have already also got our initial distance before the driver applies the brakes would be the 33 feet, which we have right here. So that means that now we are going to substitute in our V final velocity, which is 0 right here, and initial velocity, which is 44, and then initial distance, which is 33. You realize that the final distance that this person will cover will be given by 537 feet, right? So this is the final distance, and this, the total distance that this person should have covered, right? So this would be the total distance that this person should have covered from the time of reacting to the time of applying the brakes. Okay. Now that was the normal driver. So now let's look at the drunkard driver, right? So for a drunk driver, so first of all, we need to find the initial distance, right? That means the distance that person should have covered before applying the brakes or during the reaction. So first of all, we have the speed, which is 44, and the time of reaction was 3. So that means that the distance that person should have covered before applying the brakes would be 137 feet. So now, after knowing that, we need to find the final distance that this person took to stop, right? And then, so the stopping distance for a drunk driver can be obtained from the same equation, which is v squared is the same as v naught squared plus 2ac into s minus s naught. But we know s naught as 137. We know that the final velocity will be 0 and the initial velocity is 44. So that means that if we tabulate that, we shall have the final distance that will be covered, the total distance that is covered from the time of reaction to the time of applying the brakes would be 616 feet, right? So this is the total distance that the truck driver will have covered, right? So now we have found that, right? So having known that, so we now can deduce and perhaps write your answers, but probably now having done that, we are going to have some assignment, right? And this assignment is for you guys to hand in. And this assignment, I've already put it on the online system or on the online class. And the due date is already there. So please make sure that you submit your work. This work should be handwritten. Remember, you have to put your name, registration number, but it should be handwritten in your own handwriting, and perhaps please do not hand in some other person's work, right? So please make sure you observe and respect the deadline for this work. All right. So let's end the presentation with the quote of the day. Says that there is nothing that I believe in more strongly than getting young people like you interested in science and engineering. Why? For a better tomorrow and for all humankind, right? So those are the words of Birinei, and this will bring us to a close of today's lecture. And I hope you guys have a great time. Right. Thank you.